All right, Mr. Rops here.
And Mr. Cole.
And we are going to learn rules about indices. Good British term. In North America, we call them exponent rules. Be culturally sensitive.
Just to be different.
Yes, just to be different. British are different with indices. Okay, so the first one, we're going to develop some of these rules. It says, expand to simplify a cubed times a squared. And then we're going to generalize the result. Well, we know that a cubed means a times a times a. That's a cubed. And we also know that a squared is a times a. And so when I look at those, I have, this is equal to a to the power of 5. And so what we can do is if we multiply, I really add my exponents. So if I generalize this, I could say if I have a to the p times a to the q, that's going to equal to a to the p plus q. They add together. Okay, let's do an example of that one. Mr. Cole, an example for me?
All right, so this only works when you've got the same base, right? So say we have, whatever, 3 to the power of 4 times 3 to the power of 6. Then we end up with 3 to the power of 24.
Or 10. Because we add the exponent.
That's the trick. That's the trap you don't want to fall into.
Exactly. So we add them together and we get 10. Right.
Ooh.
So similar with divide.
Good start.
That's why we do it together, so we can catch each other's mistakes. All right. So expand to simplify. We have this scenario. Let's do the same kind of idea. So I have a times a times a times a times a over a times a. And so when I have this scenario, what happens here?
Okay, so we can do some cancelling, right?
Right.
So divide the top and bottom by a, divide the top and bottom by a.
Why can I cancel these out?
They're just becoming ones, basically, aren't they? If you're doing a divided by a is 1, and a divided by a is 1
right.
on the top and the bottom.
So I can eliminate those ones, exactly. So when I do that, I end up with just a cubed. Well, if I look at this, the same basis, how can I get 3 from the 5 and the 2?
Okay, so we're just subtracting.
Right, it's a 5 minus 2, which is a cubed. So the general rule says if I have a p over a to the q, it's the same thing as saying a to the p minus q. Okay, there's the general rule of that. So if I do an example of this, let's say I have a to the 7th over a to the 11th. Okay, when I have that, I get a to the 7 minus 11, which is equal to a to the negative 4. And negatives are okay to have. We can have negative exponents. And next lesson, you'll actually figure out what those mean. But those are fine to have. Okay, let's try another example, or another type of scenario. Another rule. So I have a squared all to the power of 5. So that's saying a squared times a squared times a squared times a squared 5 times.
Yep.
And if I use the previous result, when I multiply them, what am I actually doing to these exponents here, Mr. Cole?
So you can add them up.
2 plus 2 plus 2 plus 2 plus 2 is 10. Well, there's got to be a shorter way to go from here to here. And to do that, what you do is you just multiply the 2 and the 5 to get the 10. So to generalize, if I have a to the power p all to the q, that's the same thing as saying a to the p q. There's my rule for that. So an example would be if I took, let's say, let's not use a, let's use a different letter. Let's say x to the cubed to the 7th.
Okay, so now we get x to the 21.
To the 21.
Yay!
Yay! You got that one. So this one's multiplying. The one previous is adding. All right, another one to do. AB cubed. Well, that's the same as saying AB times AB times AB. Well, if I look at the A's, that's A cubed. There's 3 of them. And there's 3 B's they add together. So to generalize this rule, if I have AB to the power of P, it's just A to the power of P, B to the power of P. And that exponent belongs to both of the things inside. So if I have 2x cubed to the power of, let's say, 4, well, that's going to be 2 to the power of 4 times x. You multiply them to the 12. 2 times 2 times 2 times 2. Well, 4 of them is 16. X to the 12.
Done.
All right. There we go. 2 more to go, and then we're going to wrap this one up. So expand to simplify over b to the power of 4. Well, very similar. I'm dividing. It's ab over ab. AB, there's 4 of them. And that's going to be a to the power of 4, b to the power of 4. So to generalize it, if I have ab to the power of p, I get a to the p, b to the p.
Okay.
And finally, the last one, the 0 exponent. Well, if I have anything, let's make up something crazy, y cubed negative. If I have that to the power of 0, 0 here, that is always
1.
1. No matter what's inside here, it is always 1. That's just something you got to know.
Okay.
Good.